Hello, Mr. Eric, Mr. Ryan, how are you today?
Good.
Remember, a few days ago we talked about the four sum, yeah? Four sum. So, given a list of numbers 1, 3, 5, 2, 6, 9, 10, and 7, we want to find if they are full numbers. These are unique numbers, okay? If we want to find if they are four numbers adding to like 13, can you find it? No, 16. 16. Can you find four numbers adding to 16? 16.
Can we be multiples?
No, you can only pick one number each. Yeah, pick the number each. Can you find the four numbers adding to 6?
Wait, I know.
Yeah.
10, 3, 2, 1. Wait.
10, 3, 2, 1. Yeah, we are done. Wow, so quick. Yes. 10, 2, 3, 1. Okay. Or 7, 5, 2, 6. Okay, not multiple, but as long as you can find four numbers.
How come it's 7, 5, 2, 6? That's not 16.
Why is it not 16?
I thought you said 7.
Oh, okay. 3, 5, 2, 6. Okay, sorry.
Okay.
Okay, so remember a few days ago we talked about the brute force, right? Remember? And depth of search, yeah? Brute force and depth of search. Remember? Alright. Yeah? So for the first number in range, let's say n, yeah? Sorry. N, right? Alright? And for j in range, remember? N plus 1 n, right? For k in range, alright? J plus 1 n, right? And can you tell me what's next? For, let's say, u in range, what? K plus 1 n. Yeah. Basically, we want to loop four numbers. That's the first number, that's the second number, that's the third number, that's the fourth number. Each number is the previous number.
Why is it I, J, K, U?
Or you can say A, B, C, D, doesn't matter. It's a variable.
Underneath Eric, Ryan,
Mommy,
Daddy.
baby. Okay, and then look, then you can say if nums I plus nums j plus nums k plus nums u equals k equals target, yeah? Then return true, right? And at last return false, right? This is the brute force, yeah? What's the time complexity for this one?
O, n times 4.
O(n) to the power 4, yeah? Not times 4. Times 4 would be times 4, right? It's O(n) to the power 4. And we can use the depth first search, right? Remember, for each number, we can choose to pick or not pick, right? Do you still remember that depth first search? Let's remind ourselves the depth first search. Define, let's say DFS. Look, the left, target, and what? Remain, target, or the sum, and what? No, yeah, there's one parameter missing.
U, K.
So we want to pick the numbers, and for each one we pick or not pick and count, right? Right? Yeah. So look, if C equals 4, then we return. Do you still remember? If we have picked four numbers, we want to check if the target remaining 0, right? Yeah. If left bigger than equal than length of numbers, we return what? If we have already run out the numbers.
Return false.
Yeah, this left is the numbers
yeah.
here, yeah? And then we can return what? Return DFS L plus 1 T minus, if we pick, yeah? T numbers L, right? And then count plus 1, right? If we pick the numbers. Or we not pick, right? We not pick L plus 1 T and then C, right? Does it make sense? Depth first search, yeah? Do you still remember this a few days ago? Yeah? Yeah, Harry? What's the time complexity?
O(n)?
What?
1.
O(n) what? It's basically the same as brute force. Come on.
N to the power of 4, baby.
The space complexity is O(n), okay? Why is O(n) to the power 4? Because we are returning when the count equals 4, right? Does it make sense? Yeah? Okay. Do you still remember 2 sum, 3 sum, and then we talk about the 4 sum? 2 sum, 3 sum. And in order to do this sum, we need to.
How about one sum?
There's no one sum. Okay.
How come?
Oh yeah, one sum. Yeah, it's true. Find the number which equals the target in the list. Then we can do what? We can use the what kind of data structure?
Notebook. Set.
We don't need to use the actually. We
Set
don't need to.
forcing.
Yeah, we just go through the list and find out. Okay, if this is the target, boom, we find it, right?
Yeah.
We don't even need to use that. Yeah. For I equals that in the target. Yeah. For I in numbers, if I equals target, return true. Right? Yeah. Yeah. Does it make sense? Or look, if it's one word.
Talked about that.
Look, what's the one sum? You can use the.
Now invent it.
Eric, it's a notebook as well. Look, you can say, look, return if the target in set nums. Okay. Or you can just do this nums. You can target in num. Okay. That's one sum. Okay. One sum. Eric. One sum. One single num. Okay. Two sum. Two sum. Remember how to.
You need to define, don't you?
Yeah. Okay, define one sum. One sum, okay. Eric, nums target line. Okay. Two sum. Define two sums. Remember how do we define two sums? T num. Now,
Column.
yeah, we can use the notebook. Yeah, remember? Yeah. Or we can Or we can do what? We can sort the array and then have 2 pointers. Remember, when they are equal, we find it. When they are smaller, we increase the left pointer. When they are bigger, we reduce the right pointer. Remember? Look at 1, 5. If this sorted, yeah. If we want to find if their numbers equals to 8, two sum. Yeah. This is the left pointer. This is the right pointer. Left and right pointer added together what? 11. 11 is and compared to 8 what? Bigger. Yeah?
So you need to move the
Yeah. Okay, now 7 plus 1, 8. Okay, we found it. Okay. If it's smaller, we move the level, yeah? Yeah? Can we apply this thing to the 4 sum? You know, in the 3 sum, we can use this on the third number, right? Yeah? Eric, 3 sum. What's 3 sum? 3 sum, we make sure this array is sorted, and then we iterate, brute force the first number, and then for example, if I already pick the first number is this one, and I can apply 2 sum in here, right? Yeah. If I choose the first number here, I can apply 2 sum. Does it make sense? And how about 4 sum? 4 sum, Eric. Eric, what's 4 sum?
How about you haven't done 3?
Oh, remember, pick this one. Let's do some. Okay. If I pick what's 3 sum? I pick 2 numbers, and I apply 2 sum on the remaining set. Okay? Does it make sense? Alright, you hear me? Yeah. Does it make sense?
Yeah.
How about 4 sum? I pick 3 numbers, and then I can apply the 2 sum on the remaining. Then that's the
Target.
that's the 4 sum. Yeah. Does it make sense, Eric? So basically, for this kind of sum problem, we can do what? We can sort it the array first. Make it sorted using O(n) log n time, right? Eric. Yeah. And then we can pick the first n minus numbers, right? Then that's O1. Okay, let's say I want to do this k sum, right? One strategy is to sort this array using if this k sum and an element. The time complexity for sorting is O what? And what? Log n, right? Sorting, yeah? Sorting element. And then for this k sum, I want to brute force k minus 1 elements. Eric. So what's k minus? If I want to k minus element, so what's this? N to the power of k minus 1. Right? Yeah? Alright? Does it make sense?
You need a closing bracket.
Closing bracket. So is it right?
Maybe
if 2 sum
maybe it's not.
2 sum is O(n) squared. 3 sum is O(n) 2 sum is on square?
Maybe it is. Maybe it's not.
Look, if I do this left and right, and right, that will be on, right? On minus 1. So on. 3 sum. 3 sum I would have on k minus 1 times n, right? Yeah. So you basically. Okay. So 3 sum is basically if I'm 3 sum, so k equals 3. K equals 3. So O n k minus 2. 3 sum. I pick up one number, pick the second number, and then apply this. No, I don't pick the second number. Sorry, mistake. So I pick the first number and I apply the 2 sum on the next. So it's OK. So basically we're reducing the complexity from OK because we know O n k. We can do this k sum using k times loop, right? So O n k. This is time complexity. But you applying these 2 sum on the rest 2 numbers, we are reducing it to OK minus 1, right? Does it make sense? Yeah? Mm-hmm. Look, 3 sum. Let's do this 3 sum, for example, okay? 3 sum. 3 sum, if you have 3 lumps, for I in k range, for j in range, and then for k in range, that's O and 3, right? Alright. But instead of doing that, I can do this one loop. I pick a number first, that's n, O n. And then I can apply, look, 2 sum on the rest. That's another n, so it becomes O n squared. Does it make sense? So we are improving the complexity from O n cubic to O n squared. Yeah?
Yeah.
Okay, so can we do this on the 4 sum? Can we do this on the 4 sum? Alright. Can you do this on the 4 sum? So how can we do this 4 sum thingy? Define 4 sum, right? Lump target, right? Look, n equals length nums. Okay, now we need to solve the number. How can we solve the number? How can we solve the number?
So nums dot sort.
What's the time complexity? What's the time complexity for this? When we talk about sorting, O n log n, come on. Yeah?
Okay.
Okay, now 4 sum, so we need to brute force the first 2 number and apply the 2 sum on the rest, right? Yeah? Mm-hmm. So for the first number, I in range, let's do this range, n, right? Second number, for j in range, I plus 1, n, right? Right? Alright. This is 2 number. And we want to apply the next 2 number, A and B, okay? A, B equals what? So look, here is number. I pick the first number here. I pick the second number here. And where's the third and fourth numbers at the beginning? Here, this bit, yeah? So this is J plus 1, and this is what? N minus 1, right? Yeah? So A, B equals what? I, not the J, yeah, it's J plus 1 and N minus 1. Okay, now this common X equals, the sum equals nums I plus num J plus what? Plus
nums.
Which number? Which number? Come on.
J add 1, N minus 1. That's fine.
A and B. Come on. I already have this A and B. Okay. Okay. So now this is the current 4 sum. Okay. Yeah. But this is sorted. Remember, we make sure these 2 numbers are chosen, and then we want to try this. We want to apply the 2 sum on the least one. So if x equal t, great. We found it. Return what?
True.
Wait. If x bigger than t, what should we do?
Return false. Return true.
Come on, if this sum is bigger than t, so we know we want to move.
Return t.
We want to move which
Return
pointer?
T. We do J.
Return T.
J add 1 and
Is it J? No.
I add 1 and N minus 1.
this A and B. Okay, it's not A is
Okay,
here.
fine. A add 1 and B minus 1.
If this is bigger, adding bigger than T, so what should we do? Which I should move this here or move the A to the
B minus 1.
and A as what?
A add 1.
Yeah, come on.
And then
Return where?
it's 4.
Does it make sense, Eric? Ryan, look. Is it okay to you? Look, try the first number, try the second number. And then I have picked 2 numbers. So how many numbers I left? I need 2. So I pick the third number is A. Numbers at A. The fourth number is numbers B. And then now I add all these 4 numbers. Yeah, X. You find the target. Great, we return true. If the sum, look here. If the sum is bigger than T, we need to move the right pointer. Yeah? Because there's no point in moving the left pointer because it's sorted already. If keep moving the left, what happens? It's still bigger, right? So we move the big. And if it's smaller, we add 1. So look, this is ON square, and then another ON cubic. Compared to ON brute force or depth first search, right? Yeah? Does it make sense? If I look, 2 sum, remember, 2 sum, we just remove this. Hey, yeah, 2 sum. No, 3 sum, sorry. 3 sum, we remove this, right? 2 sum, we remove this. Yeah? You see? So this part is 2 sum problem. This part is 2 sum, right? You see? 2 sum.
Not really.
Oh, so we forgot something. We forgot the y a smaller than equal b, right? Okay. Alright. Why the left pointer is not smaller? Is smaller than b pointer. We keep doing it, right? Does it make sense? Yeah.
Is it while A smaller than B should go
Where down?
behind? Yeah. That's stuff.
Yeah. Okay. So A and B and why A smaller than B do this, right? Right. Now, so this is the 2 sum, right? This is the 2 sum, right? Yeah. Adding 1 will be 3 sum. Adding 1 loop will be 4 sum, right? And 5 sum, what happened? We added 1 now. 6 sum, 7 sum. Does it make sense? So 2 sums, we left the 2 sum at the end, 2 numbers. If you want to pick 4 numbers, let's brute force 2 numbers first, and then the rest I can apply 2 sum, right? Yeah. What's the time complexity for this one?
O and cubic.
Wait, what's the space complexity? What? Are we using a new space?
1.
Oh, 1. Look, we have a complexity here, but this is smaller than ON cubic, right? Yeah? This is smaller than ON cubic, so we can disregard it, okay?
It's better if we can disregard this one.
No, because this is so much bigger than that, right? Does it make sense?
And this one is much smaller than that. Yeah, let me see. Yeah!
Okay, here. Wow.
Okay, it, and then, okay. And then you say T, and then I remember there's return.
There's no return, come on.
Oh, wait, and, I know.
We are comparing
T
that.
minus 1.
In what case, T minus 1?
Oh, if T bigger. Smaller. Bigger.
If the sum.
Smaller.
Okay. Smaller than, and what?
X.
Okay.
I mean, maybe this.
Yeah, x bigger than t. What I wrote is x bigger than t. It's the same as t smaller than t smaller than x. Okay. It's this is a 4 sum problem. Okay.
Big box thing.
Okay, that's it. That's it for today.